You need to be able to understand multiplication of polynomials with one another in sort of three different ways or three different contexts. And I'm going to illustrate all three of those here through the example of taking this binomial of 2x plus 3 and this binomial of x plus 4 and finding the product of those two particular binomials. So the first way I want to show here is by using an area model. And specifically, I want to use a rectangle and the determination of the area of a rectangle to represent this multiplication. So when you think about finding the area of a rectangle, right, you can just take the length of its width and then the length of its length and multiply those two together to get the area, right? So if we're going to use these two things to kind of be like a length and a width, then if we multiply them together, it should be able to determine the area of a rectangle, right? So let's just say that the 2x plus 3 might be the length of a rectangle. So if we think about like pictorially how we might represent that, if like this little segment right here is going to be x long, right? And if we want something that's going to be 2x plus 3 long, then we want something else that's going to also be x long and then plus 3. So maybe that right there is like 3 long. So from one end to the far other end, that's going to be 2x plus 3 long, right? And then we want the other dimension right here, the x plus 4, to kind of be the width of the rectangle. So that means that we're going to have to go exactly the same distance as I went with x, right? So that's going to have to be x, but then plus 4, so just a little bit more than 3, right? So that's about 4 long or so in comparison. So that just kind of generally represents what the dimensions would be, and then of course I can draw these other matching side lengths here to be able to form a rectangle. And so what you're going to see come out of this here is then if I kind of section off pieces of this rectangle, so by like sectioning off sort of like this part of the rectangle and this part and then finally this part right here, you're going to see that if I just focus first of all on this part or this little section right here, that's kind of a smaller rectangle itself, which has a length of 2x and then a width of x. So if you find the area of just that highlighted yellow rectangle, its area would be 2x times x, which gives you 2x squared. So it turns out that that section right there would have an area of 2x squared. And then by a similar regard, if we found kind of the area of this little section right here, you're going to notice that the top dimension of it is a 3, but then this dimension, of course, has to match what that x is. And so if it's a 3 by x rectangle, then of course its area is going to have to be 3x. So that gives us the area of that section. It does turn out that if this right here is 2x long going from this point to this point, and then of course we know that it's 4 high, then by multiplying 4 with 2x, we end up getting then an area there of 8x for that section. And then finally the last little section, this little section right here, it's going to have dimensions just the number 3 and just the number 4. So when you multiply that length and width, then you're going to get an area there of 12. So then if we wanted to actually find the area of this, let me back up here. There we go. Of this rectangle here that overall had the dimensions of 2x plus 3 and x plus 4, then it should just be adding each of those individual rectangle pieces together. So it should just be an area of 2x squared plus 8x plus 3x plus 12, of course. And if you simplify that by combining those two middle terms, you end up getting 2x squared plus 11x plus 12. And that gives you an algebraic expression for what that area would be. And it turns out that this right here actually is the answer to what that multiplication of those two particular binomials would be. So I'll jump back to the double distributive property in just a little bit. So one thing that you may be familiar with already is kind of a FOIL method of multiplication. So in copying this problem of 2x plus 3 with that of x plus 4, what the FOIL method really gets at is that f stands for the first, and what that really means is that you can take the first term in that binomial and the first term in that binomial and multiply those two things directly together with one another. And then what this O right here really refers to is it refers to the outer, meaning that this is the outer term and this is the outer term overall. And so you can multiply the two outer terms directly with one another. And then this right here, this I, is referring to the inner terms. And so this 3 and this x right here are the two inner terms overall. So you're able to multiply those two things together together. And then finally, the L is referring to the last term in each particular binomial, which refers to 3 being the last term in the first binomial and 4 being the last term in that binomial. And you're able to multiply those things directly with one another. So that's really what the FOIL method is getting at. And when you do multiply each of those individual pairs together, so starting with 2x times x, you get 2x squared, and then you're going to have plus, and then doing the 2x times the 4 is going to give you plus 8x, and then plus, from the yellow, we get 3 times x, which is plus 3x, and then finally, plus, at the very end there, we're going to have the 3 times the 4, and then plus 12. And you can see that we get the same exact 4 terms that we just got from the area model. So of course, when we simplify this expression, we get the same exact answer to the multiplication, of course, right? And that's using the FOIL method, which will be the majority of the time how I'll tackle a lot of polynomial multiplication. And then finally, showing what I refer to as the double distributive property. This is going to be super, super, super helpful for us in terms of understanding some factoring things that we're going to get to later on and being able to recognize multiplication in this regard. So what we're going to try to illustrate right here is that if I was to take 2x plus 3 and multiply it with x plus 4 using this idea of double distributive property, what do I mean by that? Well, what I mean by that is when we normally think about distributive property, right? Normally you think like, okay, I could have some sort of a whatever, like a 3, and then I multiply it to like, I don't know, like y minus 5, right? So you take whatever this thing is right here, and it distributes in multiplication to each of the terms in that other polynomial, right? So what I need you to see is like, we're actually going to try to treat that 2x plus 3 actually as one entire thing that distributes. So what I mean by that is this entire thing is going to distribute to each of the terms in the other polynomial. So really what that just basically means then is you're just going to have then the entire 2x plus 3 multiplies just to the x. So I have to put the 2x plus 3 in parentheses, and it's going to multiply to the x. And then the 2x plus 3 also has to distribute to the 4. So I have to put a plus sign, and then I can put that 2x plus 3 again, that's going to distribute, and that's going to multiply then to the 4. Okay, and then I want to try to simplify that. So it does turn out like the x is going to have to distribute to those fellas and give you 2x squared plus 3x. And then the 4 is going to be able to distribute there to give you plus 8x and plus 12. And then you take a look at those 4 terms, and they're the same 4 terms that we've been getting. So of course, this is going to simplify down to 2x squared plus 11x plus 12. So that's how that double distributive property idea works. And like I said, seeing that and understanding how that works and is just like the distributive property is going to be really helpful for us, again, when we get to some factoring things a little bit later on.